Hello everyone. In this lecture we will discuss the two mapping, which is rotation and magnification. Let us discuss what is the meaning of rotation. So here is the definition of the rotation. The transformation of the form W is equal to e raised to I beta z, where beta is a real constant, is known as the rotation. So any transformation of the form W is equal to e raised to I beta into z, then it is known as the rotation. Now, this transformation rotate the figure in z plane by an angle theta. If the value of the theta is greater than 0, then it rotate the figure in counterclockwise direction, and if the value of the theta is less than 0, then it will rotate the figure in clockwise direction. Now, what is the meaning of magnification? Now, the transformation of the form W is equal to A into Z is known as the magnification, where A is known as the real quotient. Now, what is the difference between rotation and magnification? Now, the mapping rotation rotate the figure in Z by an angle theta, whereas in magnification it magnify the image in the Z plane. If the value of the A is greater than 1, then it will stretch the figure, and if the value of the A is lies between 0 and 1, then it will contract the figure. Now, in the definition, the transformation of the form W is equal to e raised to I theta into Z. Now, here the coefficient of the Z is e raised to I theta, which is complex constant. Again, I am repeating. In rotation, the coefficient of the z is e raised to I theta, which is complex constant, whereas in magnification the coefficient of the z is a, which is real constant. It means it is a real number. So these are the two definitions of the rotation and magnification.
Let us take the first numerical of the lecture. In this numerical, the given transformation is W is equal to 4Z. Under this transformation, you have to find an image of the triangular region which is bounded by the lines x is equal to 0, y is equal to 0, and x plus y is equal to 1. So let us start the solution of the first numerical.
In this example, the given mapping is W is equal to 4Z. Let W is equal to U plus IV and Z is equal to X plus IY. So we can say that U plus IV is equal to 4 into X plus IY. So X plus IY is equal to U plus IV divided by 4. So we can say that X plus IY is equal to U upon 4 plus I V upon 4. On comparing real and imaginary part, you will get x is equal to u upon 4 and y is equal to v upon 4. Now, in this example, you have to find an image of the region bounded by the three lines. Now, the given three lines is x is equal to 0, y is equal to 0, and x plus y is equal to 1. So these are the given three lines. These are the given three lines. First is x is equal to 0, y is equal to 0, and x plus y is equal to 1. And region is bounded by these three lines. Let us first find the images. First case, when x is equal to 0. So here x is equal to u upon 4. When x is equal to 0, u is equal to also 0. Hence, x is equal to 0 mapped onto u is equal to 0. Third line, when y is equal to 0, now y is equal to v upon 4. So you will get v is equal to 0. hence y is equal to 0 map onto v is equal to 0, and third equation is x plus y is equal to 1 for x plus y is equal to 1. Now x is equal to u upon 4, so u upon 4 plus y is equal to v upon 4, so v upon 4 is equal to 1. So we can say that u plus v is equal to 4. Hence x plus y is equal to 1 map onto u plus v is equal to 4. Now let us represent these images in z plane and w plane. First draw the z plane. Now first line is x is equal to 0. So this is the x is equal to 0 line. Second is y is equal to 0. So this is the line representing the y is equal to 0. And third line x plus y is equal to 1. So on drawing this line you will get this type of image. And this is the region bounded by the lines x is equal to 0, y is equal to 0, and x plus y is equal to 1. This is the line. Now give them O, A, B. Now this is z plane. Now draw the w plane. Now draw the w plane. This is vertical axis V, this is horizontal axis U. Now, the image of the x is equal to 0 is u is equal to 0. So, this is the u is equal to 0. Image of the y is equal to 0 is v is equal to 0. So, this is the v is equal to 0. And image of the x plus y is equal to 1 is u plus v is equal to 4. This is the line. So from the z plane and w plane, we can say that the given mapping enlarge the or magnify the region in the z plane. So this is the enlarged view of the given region in the w plane. So this is an example of the magnification. So w is equal to 4z is a magnification.
Here is the second numerical of the lecture. In second numerical, the given transformation is w is equal to 1 plus I into z, and you have to find an image of the square whose vertices are 0, 0, 1, 0, 1, 1 and 0, 1. So let us start the solution of the second numerical.
In this example, the given mapping is w is equal to 1 plus I into z. Let w is equal to u plus ib and z is equal to x plus iy. So u plus ib is equal to 1 plus I into x plus iy. So we can say that u IV is equal to 1 into x plus 1 into iy plus I into x, ix plus I into I square y. So u plus ib is equal to x plus iy plus ix. Now I square is equal to minus 1, so it is minus y. Separate real parts, imaginary part on right hand side, so x minus y. Now from these two terms take the I as a common, so x plus iy. On comparing real and imaginary parts, you will get u is equal to x minus y and v is equal to x plus y. So we have obtained the u and v. Now in this example, if 4 vertices of the square R is given and you have to find the image of this square under this mapping, w is equal to 1 plus I into z. Let A, B, C, D be the square with vertices. So now in this example 4 vertices are given. The first vertex is given is A 0 0, second given is B 1 0, third vertex is C 1 1 and fourth vertex is D 0 1. So now we have to find the image of this square under the given mapping. So let us take each point one by one. First point, for what A, now first point is A 0 0. So A 0 0 indicate that x is equal to 0, y is equal to 0. So u is equal to x plus iy. U is equal to x minus iy. So put the values. So you will get u is equal to 0 and v is equal to x plus iy. So you will get v is equal to also 0. Hence A 0 0 map onto A is, now first point is u 0 and second point is 0. Let us take the second point. For B10, now in this case x is equal to 1, y is equal to 0. So again we have u is equal to x minus y, so we will get u is equal to 1 and v is equal to x plus iy. So you will get v is equal to x is equal to 1 hence B 1 0 map onto B dash 1 1. Let us take the third point. Third point is C 1 1. For C 1 1, in C 1 1 x is equal to 1. y is equal to 1. So again u is equal to x minus y. So you will get x is equal to 0, u is equal to 0 and v is equal to x plus y. So you will get answer 2. Hence C11 map onto C-02. Let us take the last and fourth point, that is D01. For D01 we have x is equal to 0, y is equal to 1. So u is equal to x minus y. You will get x is equal, u is equal to minus 1 and v is equal to x plus y. You will get v is equal to 1. Hence D01 maps onto D. This first point is minus 1, the second is 1, minus 1, 1. So we have obtained the first images of the given 4 vertices of the square in the W plane. So under the mapping W is equal to 1 plus I into Z, we have obtained the images of the 4 vertices of the square. Now first plot this all 4 vertices A, B, C and D in the Z plane. So this is your point A00, this is point B10, this is your point C11 and this is your point B0. But by joining all these points you will get this square region ABCD. Now under the mapping, the image of the A00 is A'00. So this is your point A'00. Now the image of the 10 is B'11. So this is the point B'11. And under the mapping, the image of the C11 is C'02. So this is the point C'02. And the image of the D01 is D'-1. So by joining all these points, you will get also the square image in the W plane. Now observe that the given mapping W is equal to 1 plus I into Z. Rotate the square A, B, C and D in the Z plane by an angle of 45 degrees. So this is an example of the rotation.
Here is the third and last numerical of the lecture. In this numerical, you have to find an image of the region which is bounded by the lines x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2 in the z plane under the transformation w is equal to 1 plus I into z plus 2 minus I. So let us start the solution of the third numerical.
So in this example, the given mapping is w is equal to 1 plus I into z plus 2 minus I. So let W is equal to U plus IV and Z is equal to X plus IY. So we can say that U plus IV is equal to 1 plus I, Z is equal to X plus IY plus 2 minus I. So U plus IV is equal to 1 into X plus 1 into IY plus I into X, IX plus I into I square Y plus 2 minus I. So U plus IV is equal to X plus IY plus IX, I square is equal to minus 1, so minus Y plus 2 minus I, separate real and imaginary parts on right hand side, you will get U plus IV is equal to X real part minus Y real part plus 2 real part plus IX plus IY minus I. So u plus iv is equal to x minus y plus, to take the I from common from the last three terms, so I into x plus y minus 1. Now on comparing real and imaginary parts, on comparing real and imaginary parts, you will get u is equal to x minus y plus 2. So we can say that x minus y is equal to u minus 2. Give them equation number 1. And imaginary part b is equal to x plus y minus 1. So you will get x plus y is equal to v plus 1. Give them equation number 2. Now we have to make x and y as a subject of the equation. It means we have to find two variables x and y. Now to find this variable, add the equation 1 and 2. First add equation 1 and 2. So by adding equation 1 and 2, you will get the answer u plus v minus 1 is equal to 2x. So x is equal to 1 upon 2 u plus v minus 1. Now to find the y, subtract the equation 1 and 2. On subtracting the equation 1 and 2, you will get the answer u minus v minus 3 is equal to minus 2y. Now simplifying this, you will get 2y is equal to, take minus on left hand side, so v minus u plus 3. So finally you will get y is equal to 1 upon 2 v minus u plus 3. Now in this example, a region is given which is bounded by the lines x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2. So the given region is bounded by these 4 lines, and you have to find the image of this bounded region under the given mapping W. Now by simplifying this W, we have obtained two equations of the x and y. Let us take each line one by one. For x is equal to 0, the first line is x is equal to 0. Now here x is equal to 0. Now here x is equal to 1 upon 2 u plus y v minus 1. Now x is equal to 0, so 0 is equal to 1 upon 2 u plus v minus 1. So we can, on simplifying this, you will get u plus v is equal to 1. Hence x is equal to 0, map onto u plus v is equal to 1. Now let us take the second line. For y is equal to 0, here the y is equal to 0. Now y is equal to 1 upon 2 v minus u plus 3. Now y is equal to 0, so 0 is equal to 1 upon 2 v minus u plus 3. On simplifying this, you will get the answer u minus v is equal to 3. Hence y is equal to 0, mapped onto us take the third equation. X is equal to 1 for x is equal to 1, again x. Now put the x is equal to 1 in this equation, so 1 is equal to 1 upon 2. X is equal to 1 in this equation, so 1 is equal to 1 upon 2 u plus v minus 1. So u plus v minus 1 is equal to 2. So we can say that the u plus v is equal to 3. Hence x is equal to 1 mapped onto u plus v is equal to 3. Now, fourth equation, y is equal to 2. For y is equal to 2. Now, we have the equation of the y, put the y is equal to 2 in this equation, so 2 is equal to 1 upon 2 v minus u plus 3. Now 2 into 2, 4 is equal to v minus u plus 3. Now simplifying this, you will get the answer u minus v is equal to minus 1. Hence y is equal to mapped onto u minus v is equal to minus 1. Now first plot the region given bounded by the 4 lines. So first line is x is equal to 0. So this is the line representing x is equal to 0. Second line is y is equal to 0. So this is the line AB line representing the y is equal to 0. X is equal to 1. So this is the line representing the x is equal to 1 and y is equal to 2. So this is the line representing the y is equal to 2. So the given region is bounded by this 4 lines. So this is your given region. Now we have to find this image of this region of z plane in the w plane. Now the mapping of the x is equal to 0 is u plus v is equal to 1. So the line is this u plus v is equal to 1. Now second mapping is y is equal to 0. So under this mapping is u minus v is equal to 0. So draw the line representing the u minus. So this is the line representing the u minus v is equal to 3. Now x is equal to 1. The line is u plus v is equal to 3. So this is the line representing the u plus v is equal to 3. And last line is when y is equal to 2. So u plus v is equal to minus 1. So this is the line representing the u minus v is equal to minus 1. So this is the image of the given region in w plane. So here we have completed our third and last example. For any query regarding these lectures, you can contact me. Thank you. Have a nice day.